Students, my name is Inderpreet Singh and today we are going to discuss about sign conventions of chapter light reflection and refraction. In the first sign convention we are having the formula of lens which is called lens formula. Here you can see we are having lens formula and it is 1 by f is equal to 1 by v minus 1 upon u. Here f is focal length and v is the distance of the image formed. Here you can see in this figure this distance from the optical center of the convex lens of the image formed up to this point. This is called v. So v represents the position of the image formed from the optical center, and 1 by f is focal length, which is here between the C and the pole of the mirror, or we can say in the case of lens it is f1, 2f1 or f2 or 2f2. So f is representing the focal length, v is representing the position of the image formed, and u is representing the position of the object. V and u represents the position of the image or the position of the object. So in the second we are having the mirror formula. In mirror formula the formula is 1 upon f is equal to 1 upon v plus 1 upon u. So the basic difference between lens formula and mirror formula is, in the lens formula negative sign comes between 1 by v and 1 by u, and in mirror formula the positive sign comes between 1 by v and 1 by u. Here the same, f is representing the focal length and v is representing the position of the image formed, and u is representing the position of the object. And in another formulas we are having the formula of refractive index. Here this symbol N21, this symbol is the symbol of refractive index, and refractive index, this symbol is called refractive index of medium 2 with respect to medium 1, and it is equal to C1 upon C2. C1 is the speed of light in medium 1 upon C2 is the speed of light in medium 2, is equal to sin I upon sin R. This is actually the first law of refraction of light, in which the ratio of sine of angle of incidence upon sine of angle of refraction is equal to the refractive index, or we can say constant. And in another formula we are having N21 is equal to 1 upon N12. So basically we interchange these two positions, 21 to 12, when we write down 1 upon N12. And in another formula we are having N13, refractive index of medium 3 with respect to medium 1. So in this you can see refractive index of medium 1 with respect to medium 3. Here how will you make this formula? So you will write down first 2n, and then you will write this 1 here and this 3 here, and in between these two positions you will write down 2. This is the second medium, and first and third medium will come at first or fourth position. So I am repeating again, this 1 will come here and this 3 will come at last position for making the formula, and the second medium will come here and here, and this will be the formula of N13 is equal to N12 multiplied by N23. It means refractive index of medium 1 with respect to medium 3 is equal to refractive index of medium 1 with respect to medium 2 multiplied by refractive index of medium 2 with respect to medium 3. So here in the below we are having the figure of convex lens, and you can see here in this figure, this is the object object AB, and here the image is formed A dash B dash, and for representing the height of object we generally use small h, and for representing the position of object from the optical center we use the small u as a symbol, and for representing the position of image formed we use small v, and for representing the height of the image formed we use h dash. And you can see here, as we are having the coordinate axis sign convention, the same sign convention will be followed here, and for this upper side we will use positive sign, and for the negative for this downward side, and this right side we will use positive sign, and this left hand side we will use negative sign. So the same sign conventions which are used in coordinate axis, the same sign conventions will be used in optical sign conventions. So the distances which will be calculated from the left hand side of this optical center, they will be counted as negative, and the all the values which will be counted on the right hand side of this optical center at this side, they will be counted as positive, and this line is called principal axis. So the values which are above this principal axis will be counted as positive, and the values which are below this principal axis, they will be counted as negative. And with this we are having concave mirror and lens case, in which we have to take the focal length and radius of curvature negative. So for concave mirror and lens we will take focal length and radius of curvature r will be negative, and for convex mirror and lens we will take focal length and radius of curvature as positive. So for concave mirror and lens, focal length and radius of curvature is negative. For convex mirror and lens, the focal length and radius of curvature will be positive. And in the last we are having the formula of magnification. We represent the magnification with the symbol small m, and this is equal to h dash. It means height of the image formed upon h, which is height of the object. So magnification is height of the image upon height of the object, and it is also equal to v upon u in the case of lens. So magnification is equal to v upon u in the case of lens, and magnification small m is equal to minus v upon u in the case of mirror. So for lens it is plus v upon u, and for mirror it is minus v upon u.